Alright, so let's try example number 4. Using the chain rule, we're going to find the derivative of the function f. So this is a great example because we can kind of see that often students will think that chain rule will be the best option or the only option because they see a quotient of two functions. And I want to approach this problem with the chain rule because I think the chain rule will be much easier than the quotient rule. And why are we allowed to do the chain rule? And when you should think about the chain rule is whenever you actually have a constant, right? Meaning there's no variables in the numerator, right? So it's just a constant. For example, if you had like 11 or negative 21 on top, right? It's just a constant over a real function, right? An actual function, polynomial. All right, so let's go ahead and do that. What I'm going to do here is first is I'm going to rewrite this as a I'm going to be able to use a chain rule. I have to be able to see a function instead of function. So what we need to do is move this whole function to the numerator. So it's technically that 1 that's the numerator times the denominator. What we're going to do is we're moving the denominator to the numerator. But remember that there is like a power here, right? The whole thing is under one power. So when it's moved to the top, you're changing the sign of the power. That's the trick, right? That's the trick. That's how you're gonna be able to visualize this. And again, let's go ahead and rewrite. Let's say we have the function raised to the n power. We're gonna take the derivative of this. The inside function is g. The outside function is the power. So using power rule, I'll bring down the power, leave the inside as it is, subtract 1 from the power, and then multiply by the derivative of the inside, right? So that's what we're going to be doing here. And I'll highlight it again. The outside function is the power. The inside function is this here, right? So let's go ahead and do that. The derivative of this is going to be the derivative of the outside. So what's the derivative of x to negative 1? Well, the derivative of that, right, if you had this, it would have been negative 1 x to negative 1 minus 1. Negative 1 x to negative 2, right? Because you have to subtract 1 from the power. So we'll have negative, bring down the power, negative 1, leave the inside as it is, take away 1 from the power, that gives us negative 2, right? Negative 1 minus 1 is negative 2, and then multiply by the derivative of the inside. So here we go. Now what is the inside? It was just 2x squared plus 4x minus 1. 2x squared plus 4x minus 1, right? And so basically you have found the derivative, right? This is a product there. But we're just going to go ahead and finish up the last part, right? Still need to do the derivative of that part. So this is going to be, and because this has a negative power, we're going to move it to the denominator. So we have negative 1 times the derivative of this. The derivative of this is going to be 4x plus 4, and then all over 2x squared plus 4x minus 1. And then when you move the function to the denominator, we change the sign of the power. So there you go. That's our derivative. That is your derivative. You found it. Now what we're going to do here is finish up the problem by finding what is f prime of 2. So f prime of 2 will be whenever we plug in and replace every x with 2. Don't forget that we're going to have to square the whole thing, right? The whole denominator. So I want to make sure I extend my fraction bar there. So there you go. Let's go ahead and simplify the top. We're going to get, am I missing something here? That looks good. All right. And so what we have here is negative, and then 4 times 2 is 8 plus 4. is 12. And then for this part, we have 2 squared times 2, that's 4 times 2, that's 8, plus 4 times 2 is 8, minus 1 square. So we have negative 1 and 12 is negative 1 times 12 is negative 12. 8 plus 8 is 16, minus 1 is 15 square. And then we know that negative 12 and 100, well, 15 is the same thing as 15 squared is the same thing as 15 times 15, and we can go ahead and simplify a little bit here. You can just use a calculator for this one, but we know that 12 and 15 have a common factor of 3, like 3 times 5 and 3 times 4, right? So those cancel each other out, leaving us with negative 4 over 5 times 15, and then 5 times 15 is going to be 5 times 15 is 5 times 75. All right, and so f prime of 2 is negative 4 over 75. All right, so we found f prime of 2. We found f prime of 2, so I hope you guys found this helpful. Please let me know if you have any questions.